Hello there, welcome back to chapter 8. Today we're going to talk about how do we factor special products. And again, these are kind of like in chapter 7 when we talked about these things. These are shortcuts to help you out, but the techniques that we learned with factoring still work. Although when we talk about the difference of two squares, that is actually a very useful shortcut that you'll want to use. But this first one here with the difference, or with the perfect square trinomials, if you didn't recognize the perfect square trinomial, you could still factor it exactly the same way that we've talked about before. So in order for something to be a perfect square trinomial, the first and the last terms have to be perfect squares, and the middle term has to be 2 times a factor of the first term and a factor of the last term. So 2ab, if you'll remember, it's a squared plus 2ab plus b squared. So for example here, we have 9x squared, which is a perfect square of 3x and 3x. We have 4 here, which is a perfect square of 2 and 2. And then the middle term is twice 3x times 2 to get 12x. So this would be a perfect square trinomial. So when we come across these in factoring, we can first of all look to see, is it a perfect square trinomial? Because if it is, it's going to be pretty easy for us to factor. So we look at the first term here, we say, okay, is this a perfect square? It is. 3x and 3x, right? And the last term is also a perfect square, 8 and 8. So it meets our first condition. Now the second one is the middle term 15x, is that 2 times 3x times 8? Now notice here that would be 24x times 2, which would be 48x. So you can see that this is not a perfect square trinomial. So we would say no. It says explain. The explanation really is right here. Okay, so that would be how I would show my work on this particular one if it is not a perfect square trinomial. So let's look at another one here. So again, I checked the first and the last term, so I got 9x and 9x here. I got 5 and 5 here, so it meets my first requirement. Now is the middle term 2 times 9x times 5? You can see that it is. Okay, so that means this is a perfect square trinomial. So I know that it's going to be a plus b squared for my factorization. So a was 9x, b was 5, so I have 9x plus 5 squared for my factory. Let's look at another one here. So again, I look at the first terms. So this is going to be 6x, 6x. Last term, you'll notice here, this is not a perfect square. So this is not a perfect square trinomial, because 14 is not a perfect square. Okay? So we just say no, and we'd explain that 14 is not a perfect square. So on some of your homework, you will be looking at these, and again, the directions will be the same. So if it's a perfect square trinomial, like our second one was, we'll factor it, and if it's not, we'll just write no and then explain why. Okay? Now they'll also give you some fun little story problems to figure out. So we have a rectangular piece of cloth must be cut into a tablecloth. The area needed is 16x squared minus 24x plus 9. The dimensions of the cloth are of the form cx minus d, where c and d are whole numbers. Find an expression for the perimeter of the cloth. Find the perimeter when x is 11. So the first thing I have to do is I have to factor this trinomial here. Now because it's in this section, I have a feeling that it might be a perfect square trinomial. So let's check that first. Okay, so this is going to be 4x, 4x. This is going to be 3 and 3, so that meets the first requirement. Now is this 2 times 4x times 3? Well, it is. That's going to give me 24x. Okay. So, I know right away that my factoring, since I have a minus sign here, it's going to be a minus b squared. So I'm going to have 4x minus 3 squared. So I know that each side length is 4x minus 3 for my tablecloth. Alright? So, the perimeter of the tablecloth, okay, is going to be 4 times 4x minus 3. Because each side is 4x minus 3, I got 4 sides. So if I distribute that 4, the expression for the perimeter would be 16x minus 12. Okay, so then that answers the first thing here. And then it says find the perimeter when x is 11. So if I do perimeter when x is 11, I'm going to have 16 times 11 minus 12. Well, what is 16 times 11? Let's check that really fast. 176. So perimeter when x is 11 is 176 minus 12, or 164. Are we talking about any units here? Inches, right? So it would be inches. Okay, so on the story problems, to kind of sum it up, they'll give you a trinomial. It will most likely be a perfect square trinomial, so we'll check that. We'll factor it. Then we do 4 times that if it's asking for the perimeter, and then it will usually ask you to find it at a specific value. Okay, now for a little bit more useful of a shortcut. The difference of two squares. Remember that that's a squared minus b squared, and we factor that, it's a plus b, a minus b. Okay, so we're going to come across some polynomials that are the difference of two squares. And the requirements are that there's only two terms, one subtracted from the other. Okay, we can't have sum of two squares. Notice that it's only difference. And both terms have to be perfect squares. So here would be an example of difference of two squares. We got 4x squared minus 9. Again, it's a subtraction. And we got two perfect squares. So that would be the difference of two squares. So when we come across difference of two squares, it makes it a little easier for us to factor it. Now, first of all, again, we have to determine, do we have difference of two squares? Well, we have a subtraction sign here, so we're good there. But look here, 3 is not a perfect square. So right away, we know that this is not a perfect square because 3 is not a perfect square, or a difference of two squares, I should say. So this is no, it's not a difference of two squares because 3 is not a perfect square. Alright, let's look at this one. Again, we have a subtraction sign, so that's good. This is going to be 10x and 10x. This is going to be 2y and 2y. So, yep, it's a difference of two squares. So when I factor it, I'm going to have 10x plus 2y and 10x minus 2y. Okay? And there was a gateway problem. So I think that's all we have for this particular section. So again, these are the special products. When it comes to perfect square trinomials, the shortcut is useful but not essential, I guess is the good word. But it is extremely useful when it comes to difference of two squares, because we haven't talked about how would we factor something like this yet. Alright? So, therefore, it's gonna, when you come across something like this, you'll probably think, well, I can't factor that, but in actuality, you can. Not this particular one, but something like this, you could factor that. So, I hope that makes sense, and if not, let me know if you have any questions tomorrow.